Hey everyone, so in this video we're going to talk about how to fine-tune a LLM model from Hugging Face, and we're going to go through various steps. I've actually laid out the steps right here. So these are the steps 1, 2, 3, 4, 5, 6, 7, 8. So 8 steps we're going to go through in order to fine-tune one of the um, models from Hugging Face. So first thing we're going to do is we're going to load the model, then we're going to load the data set, and then we're going to create our data set for fine tuning, and I'll explain to you, what that means and why we need to do that. And then we need to tokenize our data set to get it ready to train the model. And then we're going to train our model, and then we're going to push it to the Hugging Face hub, and then we're going to reload our model back into our notebook, and then we're going to test our model against for the results of how it performs after the fine tuning. Now, we're not going to do a crazy kind of like a fine-tuning process here. This is more for demonstration purposes to kind of explain how the process works, and then later on you can basically follow these same steps, but you can spend more time and run the training process for a much longer period of time and do a better job. Okay, so the first thing we're going to do is we're going to install our libraries. So pip install transformers, datasets. We're going to need datasets, evaluate, and transformers. We're also going to bring in the PyTorch dependencies because we're going to be needing them throughout this project. So just put in this as well. So that's what we do. And then let that run. Now, one thing to keep in mind just before actually you do this, you do need to connect to a basically a runtime, and I recommend to go with a T4 here. Now with Colab, you do get some free runtime. So if you just go here, change runtime, you're going to initially start off with just being on CPU. You do need to be on a T4, and because just the computational work that we're doing is going to be pretty heavy, so we definitely need something like a GPU to run this process. Now, if you're a complete beginner, I will make a separate video on how to actually set all this stuff up and get started and how to like work within Colab. But this is more for some people who've a little bit have some familiarity with machine learning and working with Colab and stuff. I just want to get sort of an overview of the process. So we've installed our libraries. Now what we're going to do is we're going to load in our model. Now to get our model, to get this kind of code, you don't need to really worry about it. You just need to like figure out what model you want to work with. This is the name of our model. Okay, so all we're going to do is like look for that. And so here we are. We're going to go into Hugging Face. I'm going to show you the screen. And this is our model right here. As you can see, it's got 406 million parameters. And it's a, BART. And another thing I can say about it is an F32. So just keep in mind, this is the precision of the model. So it was trained on an F32. You can, when you bring it into your Colab, you can reduce the to it like an F4, and that's not something we're going to be discussing in this lecture, but just keep in mind this is the precision of it. It's a pretty good precision. This is usually what you look for when you for like a well developed model in terms of its precision. You can get fairly good accuracy with it if you run it on F32. Now with F32, keep in mind you do need a higher computational need, and that's why we're using the GPU. Anyway, digressing here. So here we go. In order to use the model, just go to this button right here. It says use this model. Click on transformers. And as you can see right here, load the model directly. We're going to press copy, and then we're going to come back into our Colab notebook. And this is exactly the same code that we just copied. Bring it here. We would essentially run it. Now, I'm not going to go through this process and run it again. I've done this process. I just want to kind of briefly go over the process here. So we're going to load the model. And then once we have that, we need to go load our data set. So we're now finished this section. We're going to move on to step 2 here. Load the data set. To load the data set, we need a data set. And we're going to get that from Hugging Face as well. So we're going to go into Hugging Face and have a separate tab here. This is our data set. Now, to find data set is fairly simple. You can either search for it or you can go to the data set tab right here and basically, select the type of data set you're looking for. You can go to text and you guys look through all the different data sets and find something that works for you. But I've already done that. So this is our data set. It's basically like a set of text and a headline that describes it. So you can think about it as like an article, kind of a short description article kind of thing, and then like heads. But it's not very long, the text. I looked through it. And what I was thinking is what we can do is kind of try to fine tune a model so that it can read the text and then it can create a headline for us. And we're going to try to make it so that it mimics the kind of headlines that we see here, so that anytime it's fed, a new set of text, it kind of creates the headline in the format that we kind of make it here. Okay, so that's the goal here, is to kind of create a fine-tune a model that creates headlines in this kind of format. Okay, so that's the plan. And same process, we're going to say use this data set. We're going to click on the Hugging Face option, and this is the code again. Same thing, we're going to press copy, and then we're going to come in to our notebook and we're going to paste it in and we're going to load it. Once it loads, you can see here we saved it under this variable ds. We can kind of look at it. As you can see here, it's got two features, headlines and text, and basically it's 98,401 rows of data. That's very large, right? So let's take a look at what this kind of the features look like. So we're going to see, going to the train, so train right here, we're going to look at the first row under the text. So we're going to look at the text. So this is what the text looks like, the first one, okay? And then the headline for this is basically this right here. Upgrade learner switches to career. So it's sort of like a headline. All right, so we have our data set, we have our model. We're going to step 3, create dataset for fine-tuning. Now, what happens is that this data set doesn't have a train or validation split. And some data sets that you get from Hugging Face are set up that way. So you're going to have to create your own out of this basically trained data set. We're going to have to split it. Sometimes you do get splits already done for you when you load in data, so that's kind of easier. In this case, it's not. So we're going to do that ourselves, which is good because we get to kind of learn from a different approach, which is the harder approach. So create our data set. First of all, we're going to take a subset of this. We're going to take about 1,000 samples. The reason is because training takes very long, and especially when you're just trying to like play around and learn the ropes, there's no point of going through the entire 9,000, almost 10,000 rows of data. Thankfully, Hugging Face has no fees and stuff like that. But once it starts getting, when you try fine-tuning like an OpenAI model, on which we do another video on, that'll get quite expensive. So for the purpose of just kind of like training it, for the purpose of learning, we're just gonna pick our 1,000. Okay, so that's what we did here. Take a subset, but I just took basically the first 1,000 data sets or rows of the data set, and we sorted in data set right here. And as you can see right here, everything's the same except now we only have 1,000 rows. I just kind of looked at the first, 5 kind of rows within the data set, just to kind of see how it came out. Pretty straightforward. And now what we need to do is we need to create our test and validation split off of this 1,000. Okay. To do that, we do need to convert this into a Pandas DataFrame. The format this dataset is in at the moment is good for training a Hugging Face model, but it's not a format that we can use to basically in sklearn in order to split off of it. We need to create an independent data frame in order to do that. And that's what we're doing right here. Basically, we're taking the data set, which is ds train, taking a train here. And then we are going to select the 1,000 off of it. And then we're going to basically convert it to pandas. Basically, it's almost like if I just took this and then convert to pandas. It's the same thing. Okay, so df is the data set that we're going to use now in order to create our train and validation and test. The first thing we're going to do, so just before I tell you, the split that I decided to do is to keep 70% of the data as training data, and then 15% as validation, and 50% fairly what a lot of times happens, but you can decide how you want to split it depending on your data set and use case and all that kind of stuff. In this case, I just kind of kept it simple, 70, 30, 30. Okay. So the first thing we're going to do is we're going to split off our test out of the entire 1,000. We're just going to split off the 15,000, the 15%, and this is how we just run our train test split. We run in our data frame, which we created. And then we set test size 15 and random state 42 in order to get the same basically result back every time. And then over here, we take the remaining of this, which is the 85%, and we take 15% off of that for our validation. And then the remaining balance ends up being our training. Okay, so this is our training validation, taking 15% off of the 85, which is 178.176, and that's what it is. So I'm just going to, because this is kind of be confusing, but anyway, that's what's happening. You can see here, I printed off the size of our different variables. So we have train 700, 150, 150. That matches what we discussed. Okay, just quickly looking at our train, as you can see here. Now you have to keep in mind is our indexes are not going to be necessary going from 0 to 1, 0 to whatever number. Okay, so we're basically splitting off the data set at various points. So here you go, it starts from 90, not 0. Just keep in mind. Okay, so this is our test validation. Perfect. So we got our data set. I'm going up to show you the next. Create data set for fine tuning. That's done. Next thing we're going to do is we're going to tokenize. Going back down, tokenize. We're going to import data set from datasets. What we're going to do now is, in order to tokenize, we need to convert it back from the data DataFrames into a data set that is acceptable for tokenizing and for training models. So basically the original format that we had our data set, we're going to get back to that again. And so here we are. I call this the train data sets, and we're just basically taking our training data that we got from the split earlier, and we're going to run it through this, and we're going to get train data set, and we can get a validation data set. So we got our train data set and validation. The test doesn't need to happen because the test, all we're doing is just we're going to be using it to test the LLM layer. So that doesn't need to happen. I made a little function here, tokenize inputs, and what it does is it creates a prompt. It runs every row in our training data set that we have. runs it against that prompt, and then tokenizes basically the result. And also we're going to tokenize the headline. So remember, we have a text headline, we have a text feature, and we have a headline feature. And that's what we're going to do. So we're running it through, and we're going to tokenize basically our entire whatever we run through. In this case, I'm just talking about train, but we're going to same thing is going to happen in validation. So that's the function, what it does. And then afterwards, what it does, it creates three columns. One is going to be called input IDs. One is going to be called attention mask, and one is going to be called labels. And these are the three columns that we're going to need to feed into the training process. That when we're training our LLM, we need these three. So at the end, we're actually what we're going to have is these three features in our data set, and you're going to see in a little bit. So that's our function. The padding token is something to keep in mind. So padding tokens and end of sentence EOS, end of sentence. So padding tokens is basically what your different features. So for instance, those texts and stuff, they might have different lengths. And so it's very important to keep everything consistent across every row in terms of the number of characters and tokens and stuff like that. In order to keep it consistent, we add padding. So let's say something is short in its padding. Sorry. Let's say something is kind of a fairly short piece of text, and another row is another, like a longer piece of text. The shorter piece of text gets sort of padding tokens, so that they're both the same size. So that's what padding basically is. End of sentence tokens is just something that tells the model that this is the end of a particular sentence. And sometimes there are ways to control output after sort of, for instance, to say stop producing text after you read the end of token sentence. So end of sentence token, sorry. So that's what this basically is. So I wanted to see if this model, this tokenizer has it, because some tokenizers, some models don't have it. So in this case, it does. And for the tokenizer, it is this token right here, pad. And for the end of sentence token, it's this right here. Okay. So for a training data set, this is basically what it looks like currently. Headlines, text, and index level 0, this thing right here. In order to get it to kind of have only these features at the end, we're going to need to get rid of these guys. And we'll do that right here. So here's what the actual tokenization is happening. So first thing we're going to do, we're going to map every single row against and basically tokenize every single row. This is what this means, just mapping the process. And then we're going to remove these, because at the end of this, there's going to be 6 features in this, in the data set, for instance. So we're going to remove index level 0. We're going to remove text. We're going to remove headlines. And I'll show you what that means. So once we run the tokenization process for both the validation and text, we have 3 left, 700, and I'm going to show you. See the difference now? Input IDs, attention mask, labels. Before, headlines, text, index level. So that's what this is. Okay. Length of our tokenized data sets. So it's 512. Why is it 512? Because we set it. Max length 512 right here. Okay, I'm just looking at stuff right now just to see how everything went. Okay, next thing we're gonna do is we're gonna run our Hugging Face hub, and we're going to log in. And it's a very straight process. You're going to run this code. It's going to ask you for an API key. You're going to go into Hugging Face account. Under your your profile, you're going to see basically your secret key. You can grab that secret key. Same process as you would do, for instance, like for if you're running in your notebook an OpenAI key, for instance, and you want to get things. Except this one gives you kind of a GUI kind of login process. So you're just going to grab your key, you're going to put it in, and you're going to log in to Hugging Face. You're going to need this, very important, because if we're going to push our model to Hugging Face, we're going to need to log in. So here's the next stage. So now we're here. Let's go back here again. So we've done this, training our model. So this is the code to train your model. The hub D is basically the name of your, so you're going to start up with your profile username, and then you're going to put slash, and then you're going to put a reference to the model, as well as the data set that it was fine-tuned under. We put our learning rate. We're going to train it on 1 epoch. So you're going to see this is not going to create like the craziest results, but we're just trying to like, just to kind of show how it works. Then we're going to run the trainer, and it's going to run the model that we've basically run into it. Here's the code to train it actually. So this is just to kind of get it prepared. Then we're going to go train it. This is the actual training process. Now, once you run this, it's going to ask you for your weights and biases API key or secret key. You'll need to create an account with weights and biases. I'll show you real quick. This is weights and biases. You're going to log in. You're going to create an account, same process. And you're going to grab your key and you're going to stick it right here when it asks you. You're going to wait for this to finish. It can take some time. So this is where it was very important to not pick such a large number of rows, and also keep the epoch fairly small, because I don't want it to run forever. I'm just kind of want to show how this process works. Next, we push our model to the hub with this code right here, training.push to hub. And now when you go back into your Hugging Face, you will see that, show it right here. You go to your profile, you will see that it'll pop somewhere here, which is basically, that it's been uploaded. Okay. And then we're going to load in the model now in order to use it. So we're going to go load model, auto model for sequence. So basically this is the code, and this is what we call our model right here. Okay. So we're going to load it, and then we're going to test it. Okay, so we're right now at the final stage. Load the model, and you're going to test the model. This is the final stage. Almost there. Going back, sorry. Okay, now this is our test data set. It's got 2 features, text and headline, remember? And keep in mind, this is the starting point of the index. So if you want to see the first row, you're going to have to put in that number in here. And that's what I did. I just want to sort of run it through. So this is the first, basically, text and headline. That's the text, that's the headline. And I call the text sample, and label is the headline. Just variables I picked for the purpose of what we're doing. I wanted to see what kind of configurations are available on the regular model and the fine-tune model. So this is just something just interesting to see. Like these are all the things you can modify and you can play with. Okay. I created a function to generate a summary. So what we're doing is basically create a catchy headline for the following news text. This is our news text, and this is the headline. So we feed in the input text, which is it's going to be the sample text later. And then we're basically prompting. It is the initial prompt. What we need to do is we need to create our input prompt, feeds into this. In order to tokenize it, we need to tokenize our input prompt. And we're going to store it as input IDs. And this is going to happen for every basically time we send in the sample in. And then we're going to tokenize the output. Okay, and these are the kind of features that I set here: minimum length 10, maximum length 10, number of beams, basically, so to just better search results for beam. It's an optional thing. These two are fairly optional. I would probably keep these. And basically we're going to feed these input IDs into our input IDs variable. It's part of the LLM.generate. And then the output is going to be tokenizer that decode. We're going to have to decode. So we're going to first encode it, and then we're going to decode it as well to get basically the results back. Okay. So decoder, and we run it through our LLM. So whatever LLM we feed through here, this is what it's going to do. It's going to generate a text, and we're going to decode it. And we're going to take the first index of that, and then we're going to return the output. Okay, so this is our function. We went output fine-tune model, generate summary. Sample, as I said, we're going to feed in a sample here. Sample sits right here. We can grab this entire input prompt, goes right here. The input prompt gets tokenized into input ID. Input ID goes right here. Great, and then we run this entire process, tokenized output. Okay, we got the tokenized output, and output is going to be tokenized decoder. The tokenized output goes right here, the first, and then basically the output gets returned, and that's what we're getting here. Now the LLM in this case is going to be a loaded model. That was our loaded model, remember? Where is it? Right here. That's the model that we reloaded. So we're going to load that model in. And as you can see here, I said sort of like some, just to make it easier to read, this is our sample. This is the headline that we've created with this LLM. And this is the headline that was originally in the dataset for this particular set of text, news text. Okay, so this is what it was originally, and this is what we created. And you can see, it's not trained very well yet, because it says train 18, and as fast as indigenous train 18 will grow short. But you will notice one thing, that it did a better job at summarizing this than this did. This is train 18 named, but this headline captures more of like what this says into it. It talks about the speed, talks about this, like where it's going between, all that stuff. It was pretty interesting. The other thing is, when you compare it to the regular model, so remember, we also have the regular model that we started with, that we did a fine-tune. This is the fine-tune one. And we ran it through, and same process. Let's get the output, and the output looks like this. Now, this one looks like this. This is their headline. And over here, I just could have compared the two. The top one is our standard model. The bottom is our fine-tune model. And to be honest, I think the top one probably did a better job. But because here is train 18, and then train 18 again. They don't need to repeat that. But this one did not do that. However, one interesting thing did happen. See the length of this result? See the length of this? See how I got cut off here? This one, even though we didn't even say to it for to stop after the end of sentence token, it stopped by itself. So our fine-tuned did make a fairly smaller title, or sorry, headline than the regular model, the unfine-tuned one. So that's something to see. But again, it was one epoch. It's not going to do a whole lot. And in order to get kind of like the best result, you're going to have to run several epochs and play around with it and all that kind of stuff. But it's basically the process. So as a recap, we loaded into the model, we loaded in the data set, we created a data set fine-tuning, because remember, it didn't have a test and validation. We tokenize it, and in order to tokenize it, we had to convert it from the Pandas DataFrame, which we had to create for this, back into a set of data set that is acceptable to read into the LLM, and also the tokenizer. We're going to train our model after that using our tokenized data sets. We pushed it to the Hugging Face. You saw that. We reloaded it back into from Hugging Face back into Colab, and then we tested the model. Thanks for listening, and see you in the next one.